Hello children and welcome all of you to the class of mathematics. We are discussing chapter number 3, pair of linear equations in two variables. We are on the last exercise of this chapter, and in the previous video lesson we started with exercise 3.6 question number 2 and we solved two examples. Here is the third example from exercise 3.6 question number 2 and third sum. Question is, Ruhi travels 300 km to her home partly by train and partly by bus. She takes 4 hours if she travels 60 km by train and the remaining by bus. If she travels 100 km by train and the remaining by bus, she takes 10 minutes longer. Find the speed of the train and the bus separately. Children, I told you that what is asked at the end of your sum, that you have to consider as x and y. We are asked find the speed of the train and speed of the bus separately. So that will be our variable. We will let the speed of the train be x km per hour and speed of the bus be y km per hour. Now if you read the sum carefully, we are given the first condition, and the first condition is Ruhi travels 300 km partly by train and partly by bus, and it takes total 4 hours, okay, and she travels 60 km by train and the remaining distance she travels by bus. So we will consider, say, the distance which she traveled, the total distance which is given to us as 300 km. This 300 km is traveled partly by bus and partly by train. Alright, we have considered speed of the train as x km per hour and speed of the bus as y km per hour. So say suppose she travels the first 60 km distance by train, and say from A to C is the distance which she travels by train, and the remaining distance is how much? It is 300 minus 60, which is 240 km, that is from C to B she travels by bus. We are given that the total time taken to travel from A to B is 4 hours. Now how will we write our condition? So just look over here children. When she is traveling by train, distance is 60 km, speed we have taken as x km per hour, therefore time taken will be given by the formula distance upon speed. So time taken to travel by train from A to C, which is a distance of 60 km, is equal to 60 upon x. Alright, why we are considering the condition related with time? Because in the sum we are given that the total time is 4 hours. Alright, and in case of bus we have given the distance as 240 km, speed of the bus is y km per hour, and therefore the time taken by bus to cover 240 km distance is equal to 240 upon y. Alright, so let's see now how we will put up this in the form of an equation. Total time given to us as 4 hours. Time taken to travel by the train is 60 upon x, plus time taken to travel by bus is 240 upon y, and the total time is equal to 4, and this is our equation 1. Alright, now we are given the second condition that if she travels 100 km by train and the remaining distance by bus, she takes 10 minutes longer. Now just see, this is how she is traveling. By train she is traveling 100 km. Total distance is 300 km. So remaining distance of 200 km she is traveling by bus. So in this case, time taken to travel the distance by train will be equal to 100 upon x, because that is distance upon speed, and time taken to travel by the bus is 200 upon y. We are using the formula time is equal to distance upon speed. Now here the total time is 4 hours 10 minutes because it is said that she takes 10 minutes longer. Earlier to travel the same distance she is taking 4 hours and 10 minutes longer means 4 hours 10 minutes. So let's see how will we write the condition. So total time is 4 hours 10 minutes. So just see 100 upon x plus 200 upon y is equal to 4 hours plus 10 minutes, and this minutes also we have to convert into hours. So 10 upon 60 hours. Alright children, this is very important that minutes you have to convert into hours. So this 0 we will cancel and therefore we are left with 100 upon x plus 200 upon y is equal to 4 plus 1 upon 6 hours. Let us cross multiply and simplify this. So 100 upon x plus 200 upon y is equal to 4 into 6 plus 1 upon 6. That will give us 4 into 6 is 24 plus 1 upon 6, and therefore we get 100 upon x plus 200 upon y is equal to 25 upon 6, and this is our equation 2. So with the given conditions we have got two equations, but if you look at both the equations, they are not linear equations in two variables. So we have to reduce them to linear equations, and for that we will take 1 upon x as u and 1 upon y as v. So our equation 1 will become 60u plus 240v is equal to 4, and we will number this as equation 3. Now children, for equation 2, this we can write it in this manner: 100u plus 200v is equal to 25 upon 6. But since we do not want anything at the denominator, this 6 I will take to the left side and cross multiply. That will give us 6 in the bracket 100u plus 200v is equal to 25. Now I divide throughout by 25, and therefore we will have 24u plus 48v is equal to 1, and this we will consider as our equation 4. So now if you look at equation 3 and 4, these two are the pair of linear equations in two variables. Now we can solve it. You can either solve it by substitution method or elimination method, get the values of u and v. So from equation 3, which is 60u plus 240v is equal to 4, we get 60u is equal to 4 minus 240v. From this we will get the value of u, and that is 4 minus 240v upon 60. So let us substitute this value of u in equation 4, and our equation 4 is 24u plus 48v is equal to 1. So we'll write 24, then the value of u we will substitute, which is 4 minus 240v upon 60 plus 48v is equal to 1. Alright, we will cancel this. 12 5s are 60 and 12 2s are 24. So we are left with 2 in the bracket 4 minus 240v upon 5 plus 48v is equal to 1. Now you must be thinking that we do not want 5 at the denominator, so what will we do? Yes, that's absolutely right. We will multiply this equation throughout by 5. So we'll write 5 into 2 in the bracket 4 minus 240v upon 5 plus 5 into 48v is equal to 5 into 1. So let us cancel this 5. What you are left with is 2 in the bracket 4 minus 240v plus 240v is equal to 5. Again you have to simplify this. So 8 minus 480v plus 240v is equal to 5, and this minus 480V plus 240V will give you minus 240V is equal to minus 3. This minus minus sign we will cancel from both the sides. So we are left with V is equal to 3 upon 240, that is 1 upon 80. Alright, let us substitute this value of V in equation 3. And what is our equation 3? It is 60U plus 240V is equal to 4. Let us substitute the value of V. So we get 60U plus 240 into 1 upon 80 is equal to 4. Cancel this 80 and this is 83s are 240. So you are left with 60U plus 3 is equal to 4. So you get 60U is equal to 4 minus 3 and therefore you get 60U is equal to 1. So U is equal to 1 upon 60 is your second variable. But you have to find value of X and Y. So let us resubstitute the values of U and V into what we have taken. We have taken U as 1 upon X. So value of U is 1 upon 60 is equal to 1 upon X. So X is equal to 60. We have taken V is equal to 1 upon Y. But V is 1 upon 80. So 1 upon 80 is equal to 1 upon Y. That will give us the value of Y, which is 80. Alright. So this is how you can find the speed of the train as 60 km per hour and the speed of the bus is 80 km per hour. Alright children. So easy sum, but you have to think and then solve. So such sums are higher order thinking level sums and this may come for 4 marks in the exam. Please practice this carefully. So this is all about our lesson. Here we finished all the exercise and all the sums from the chapter. Here are some extra sums for you. Let's have a look at that. As I told you that the both upstream downstream sums are very, very important. So one such sum for practice. A boat goes 30 km upstream and 44 km downstream in 10 hours. In 13 hours, it can go 40 km upstream and 55 km downstream. Determine the speed of the stream and that of the boat in still water. What is given at the last statement is your X and Y. So the speed of the boat in still water is X km per hour and the speed of the stream be Y km per hour. Now in the previous video lesson I explained you about the upstream and downstream. So when the boat is going downstream, the speed will be the speed of the boat plus speed of the stream, so it will be X plus Y km per hour. And when the boat is going downstream, the speed reduces, so it will be X minus Y km per hour. What is given to us? The boat goes 30 km upstream and 44 km downstream and the time taken is 10 hours. Alright. So keeping this in mind, our condition will be related with time. So let us see how we will write. Time taken to go upstream will be given by distance upon speed. Upstream, the distance is 30, speed is X minus Y. So 30 upon X minus Y. And time taken to go downstream is 44 upon X plus Y. And the total time given to us is 10. So our first equation will be 30 upon X minus Y plus 44 upon X plus Y is equal to 10. That's the total time. Alright. Then we are given the second condition that the boat goes 40 km upstream and 55 km downstream in 13 hours. So again we will use the formula time is equal to distance upon speed. So 40 upon X minus Y plus 55 upon X plus Y. Total time is 13. So is equal to 13. and this is your equation 2. Now you have both the equations. How will you solve it? You have to substitute the values for 1 upon x minus y and 1 upon x plus y. So take 1 upon x minus y as u and 1 upon x plus y as v. Substitute, solve it, and this is your homework. You will go ahead on your own after this and get the value. Answer is flashing at the bottom for your reference. Please check your answer. Alright children. One more very interesting sum is there for you. Just see here. Points A and B are 70 km apart on a highway. Alright. A car starts from point A and other car starts from point B at the same time. If they travel in the same direction, they meet in 7 hours. But if they travel towards each other, that means in the opposite direction, they meet in 1 hour. What are their speeds? Alright, so 2 cars are there. So the car which starts from point A, we will consider the speed of that car as x km per hour, and the car which starts from point B, we will consider its speed as y km per hour. What is the first condition? That both the cars are traveling in the same direction and they meet in 7 hours. Let's see, let's have a diagram and understand the sum. Okay, you have point A, this is point B, and the distance between the 2 points is 70 km, and one car starts from point A, the other car starts from point B, and both the cars are moving in the same direction and they meet at one particular point. We will call that point as a meeting point, and they meet after 7 hours. Alright, this is what is our first condition. We have taken speed of car A as x and speed of car B as y. You know that distance is equal to speed upon time, speed into time, right? So both the cars meet in 7 hours. So what is the distance covered by the car which is starting from point A? It will be 7 into, how much is the time? 7 is the time. What is the speed? X is the speed. So the distance covered by the car A which starts from point A will be 7x. Alright. And the distance covered by the car which starts from point B in 7 hours will be 7 into y. Alright. So car A is traveling a distance of 7x from A to meeting point, and car B is traveling a distance of 7y from point B to meeting point. But how much is the distance between A and B? It is 70 km. So the difference between the distance between the two cars is 70 km. That is how we can place the condition. So we will write 7x minus 7y is equal to 70. Okay, so the distance A to meeting point is 7x, distance B to meeting point is 7y. So 7x minus 7y is equal to 70, which is given to us. We will make this equation simple, dividing by 7. So we get x minus y is equal to 10, and that is our equation 1. Alright. Now the second condition is the car travels in opposite direction and they meet in 1 hour. So the car starts from point A, other car starts from point B, and both are traveling in opposite direction and they meet in 1 hour. We will use the same condition. So in 1 hour, speed of car A is x, speed of car B is y. So the distance covered by car A is x, distance covered by car B in 1 hour is y. So according to this, we will have the second condition as x plus y is equal to 70. Alright, we will consider this as our equation 2. Now you have got both the equation, children, equation 1 and equation 2. You can solve it for the values of x and y and get the answer. An interesting sum, Please understand and complete the sum. That is for your homework. Alright. Along with that, here are some extra sums and I want all of you to solve this. These are 3 selected sums which I have given to you. All the 3 sums you can consider as hot sums. Try solving it. Answers are also given. For the second sum, you are given the hint also. Please solve it, and if you get any difficulty in solving the sum, please reach out to me and then I'll explain you. But for time being, I want all of you to try these sums and get the answers. Alright. So this marks the end of this chapter, children. Chapter number 3, pair of linear equations in 2 variables. As I said, a very scoring chapter. So please practice this. In the next video lesson, we will start with the new topic. Till then, bye and take care.